Hello everyone, I am Dr. Fawzul Atiq. I am giving some series of lecture for the course Probability and Statistics. So, till now what we did, till now we have learned to analyze problem and systems involving uncertainty to find the probability, expectation and some other characteristic for a variety of situations and to produce forecast that may lead to important decision, right? Now here several things was given, right? What are the things was given already? We were given the distribution and its parameter. I hope you remember that all the for the normal distribution. What is the distribution? We all know. What is the PDF? All these things know, right? For uniform distribution. What are the PDF? What are the cumulative distribution? All these things were given. So we were able to compute probability by considering the outcome of the experiment. And sometimes the distribution may not be given, but we have learned how to fit it to the suitable model like Bernoulli, binomial, exponential, Poisson, right? Given that from the data we try to understand and then we find the probabilities, right? So in either the cases, parameters of the fitted distribution had to be reported to us explicitly. In all the cases, the parameters we need it explicitly and they had to follow directly from the problem, right? Unfortunately, this is rarely the case in practice. So in general practice, it is not the case that somebody will give you all the parameters and distributions. You have to understand them, correct? So what you have to do, how can we use the probability technique in practice? As I said that in general, in practice, in reality, nobody will give you the parameter. Nobody will give you directly this distribution. You have to analyze it, you have to understand them, and then you make use of it. So what we'll do, we begin by collecting the data that reflects the behavior of the system, right? So your first job is to collect the data. So this data help us understand the distribution, estimate the parameters, and compute probabilities, right? So from the data, we'll try to understand. And often sometimes the full population is too large to study. Now sometimes the data is huge number of data you will be having, right? So the full population is very large to study. So in that case, what people used to do, so we collect a good sample and we analyze it. So instead of doing the analyze the whole population, we collect a sample and then we analyze it, right? So a well chosen sample can offer reliable insight into the population, right? So therefore the uh, the term statistics comes into the picture. So from the data we usually aim what, understand the distribution of the population may follow. So that you have a big population, so from the data we try to understand the distribution of the population, and then or what we do, estimate the parameters of that distribution, right? Now what is statistics then? Now the statistics is the science of collecting, organizing, analyzing, interpreting and presenting the data to make informed decision. So all these things has a some rule, right? So collecting the data, you need to do some, it is not that arbitrarily you are doing, right? So there is some rule. Then you have to organize the data, you have to analyze them, you have to interpret them, and at the end you have to present the data to make the informed decision, right? So all these things, statistics is the science of all, and it helps us uncover patterns and draw meaningful conclusion from the real world information, right? Now, what the statistics is of two types. One is descriptive statistics, another one is inferential statistics. What is descriptive statistics? What is the purpose of it? To summarize and describe the main features of a dataset clearly and concisely. Whereas inferential statistics purpose is what? To make prediction or generalization about a larger population based on a sample data. So inferential statistics is just a prediction, or you try to generalize the whole population based on a small portion of it. The key tools of descriptive statistics are measures of central tendency, mean, median, mode, measures of spread, the range, variance, standard deviation, the visualization, which is graphs, charts, histograms. Whereas the key tools of the inferential statistics are hypothesis testing, confidence interval, regression analysis, right? So later we will discuss about each of these component separately, like the measures of central tendency, measures of spread, visualization, that regression analysis, several things we will discuss in our course. Now some example of descriptive statistics is what you know, that suppose calculating the average exam score of a class or creating a pie chart to show the percentage of student by major. Suppose in your class, this probability statistics class, what is the final exam marks? We need to get the average of it. So we can clearly get it. We can collect that the whole students marks, and we can clearly calculate the average of it, right? So it is the actual fact. Whereas inference statistics example is, suppose in your area election happen, in your state election happen. Now you want to have now that the generally news channel used to predict that who will win, which party will win the election. So what they do, so using a survey of maybe 500 voters, they used to ask them, they used to ask their views, whom you have voted or who should win, like that they asked to them, and then they used to get the opinion poll, right? So using a survey of maybe 500 voter to predict election result for an entire state or entire country, right? So it is not the exact data, but it is a prediction, it is a generalization from the sample, right? So this is an example of inferential statistics. Now this then what we understand from that, descriptive statistics is what already happened, right? So summarizing the past data, what has already happened, the summarizing the past data is the descriptive statistics. Whereas inferential statistics is what might happen, that predicting the future trends or generalizing the findings, right? So it is the prediction or the generalization from a sample data. And then what is a sample? A sample is a subset of observed unit from the population. So it is a some portion of the subset of the population, some portion of the population is called a sample. And any function computed from a sample is called a statistic, right? And each statistic is a random variable since it is computed from the random data and it follows a sampling distribution. Now this, while sampling something, that you may have some biasness. What kind of biasness? So one kind of biasness is voluntary response bias. That some responses are coming voluntary. Like the scenario, consider the scenario that a radio station runs a poll asking listener to call in about a controversial issue, right? So they ask about what is the people's opinion, but whom they are asking? to the all the radio station listeners, right? All the radio listeners. Now, what is the problem here? Who are like the people who have the strong opinion? Maybe that controversial issue is there, na? That the people who have very strong opinion, they will only respond here. Not all people. Some people will simply ignore. There may be several radio listeners, but the people who have a strong opinion regarding the controversial issue, they will only respond here, right? So here, the whatever opinion they will get, it is not the general opinion. It is the opinion of that who have responded voluntarily, correct? So this is also kind of a bias, right? It is not the opinion of the whole radio listeners. It is only the opinions of the strong opinion, those who are having strong opinion, correct? So this is one kind of voluntary response bias. Again, we can have the under coverage bias. What does it mean? Consider the scenario, an online survey about the internet habits, right? An online survey about the internet habits. Now, what is the problem here? Exclude people without regular internet access. So it exclude the people who do not have any internet access, right? Regular internet access. But we are doing the online survey about the internet habits. But only the people who have very good internet, only their survey will come into the picture, right? So here the people who are like little bit elderly or who are the rural residents who may not have very regular internet access, they cannot join in this survey, right? So again, in this survey, the sampling is an under coverage bias, right? This is also one kind of sampling bias. Then the another one is convenience sampling. Consider the scenario that a researcher survey only their own students. So suppose in your institute you want to get like some idea about the some survey about the university student, then what you will do, you will only check, you will, because you have the access of all the students email id, or you can have a reach to all your student, you used to ask to your university student only, right? Because it is convenient for you, right? Now what is the problem? The problem is participants are not diverse in background. The result may not generalize to all university students. In your university, depending on your location, your region, your language, the things may be different. So it will not get the actual scenario of all university students, right? Because you have a convenience, so you pick the sample as your university. So this is kind of a convenience sampling, right? So this kind of sampling used to happen. The biasness in sampling used to happen in reality. Even like we all know that how the sampling works, right? So imagine you are cooking a soup and you taste a small spoonful to get an idea, like that is also a sampling, right? Like you want to check whether your salt is proper or not, so you used to take a spoon of the soup and you check whether the it is correct or not, whether it is properly salt is given or not. So here also you may have the biasness, why? Suppose your salt you have given but you have not mixed it properly. So one side you have given the salt and you are taking the sample from the other side. It is also a kind of a sampling bias. So it is not the properly, you have not taken the a proper sample. So sampling bias can happen there as well, right? So if you decide the whole soup needs to salt based on the taste, you are making an inference, right? So for your inference to be valid, right? For your inference to be valid, the spoonful, the sample must represent the entire pot population. You should not have any biasness. Even if you have put it the salt, it should be mixed it properly mixed. It should not stay in one side and you are taking the sample from the other side. right? So what is the key takeaway from this discussion? To avoid sampling bias, use the random and representative samples. So your sampling should not have any biasness. It should be representative from all part, right? Ensuring each population member has an equal chance of selection. And what is the statistical inference? Learning about a population using only part of it. That is called the sampling statistical inference. And what is a census? A census collects the data from the entire population, but it is often too costly and time consuming. Census is the data of the entire population, whereas random sample is a smaller one, manageable group that if it is a representative allow us to make accurate conclusion about the population, right? So sampling is several times very much useful because to collect the census, like collect the data for the entire population, it is very costly or time consuming. Several cases it will happen. So instead of going for the whole one, like for the prediction of election result, to do the election, it is very costly, right? It is lot of time consuming, lot of arrangement used to happen. But what news channels are doing? They are taking the samples. They are asking few people. So, and they also have seen that the prediction may be wrong. That's fine. That means that some kind of biasness may happen. So they have to take the representative. Sometimes we have seen that their predictions are completely wrong. Opinion poll. Again, sometimes we have seen that it is like happening very good way. It is giving the exactly appropriate result. So again, that means what? If the sampling is good, then your prediction will be accurate. So, what do we do with the sample data? So, what we'll do, measure variables of interest. So, whatever interest we have, we will measure them. Then we compute the statistics like mean, variance, range, and many other things, and use this result to estimate unknown population parameter. Now, regarding the population parameter versus the sample statistics, we have some notation. So population mean we denote it by mu, whereas sample mean we denote it by x bar. Population variance we denote it by sigma square. Sample variance we denote it by s square. And standard deviation we denote it by sigma, whereas standard deviation we denote it by s. Right? So population parameters are what? That like this mu, sigma square, sigma, all are fixed. They are the actual result, but they are unknown. Right, they are the actual result, but they are unknown because to get them it is very costly, very time consuming. Whereas sample statistics like x bar, s square, s, all are computed from the data to estimate these parameters. To estimate where x bar is the estimator of this mu. S square estimates the variance sigma square. S estimate the standard deviation of the population sigma. Right? I hope you understand this concept. Now, this kind of estimator, uh, related to that, we have a concept called unbiased estimator. So, a statistics like x bar or s square is an estimator of the parameter mu and sigma square. Yes, we have already discussed that x bar is an estimator of mu, s square is the estimator of sigma square. Now, suppose theta is a population parameter. It may be the population parameter means it may be mu, it may be sigma square, it may be sigma, which is the exact parameter. And theta bar or theta cap is its estimator obtained from a sample, right? So it is unbiased if its expected value equals to its true parameter. So this estimator will first calculate and will calculate its expected value. If it is equal to the actual parameter theta, then we call this is an unbiased estimator, right? So how we can get this is that E of theta cap over many samples, the average value of the estimator if it hits the true value. So we'll do several sampling and then we collect the average value of this that theta cap, and if it is equal to the true value, the population estimator, then we called it as a unbiased estimate. Right? So what is bias then? That bias must be the difference. So bias is the difference between the expected value of an estimator and the actual value. So your expected value of theta cap minus the actual parameter. And if the bias is 0, the estimator is unbiased. If not, it is systematically over or under representative of the parameter. And then only your opinion poll used to give the wrong result, right? So if your that estimators are biased, that means it is under representative or over representative, right? Okay. Then some error used to happen due to sampling as well. What is that? There may be some discrepancy between the estimated value and actual value. So we classified into two types. One is sampling error, another one is non-sampling error. Example of sampling error is what? Suppose we want to estimate the average height of student in a university. And then if you take a sample of 50 students, their average height may slightly differ from the actual population average, right? So this difference we called it as a sampling error. So it is very much unlikely that this 50 students average height, it give you estimates, but it should not, it will not be, it is very rare case that it will be the actual population average, it will be equal, right? There will be slight difference. So this difference is called a sampling error. The key point is, as the sample size increase, if you increase the sample size, that sampling error tend to decrease and converges to 0. Yes, it is possible. So if you keep on increase the sample size, suppose in your university or in your institute you have 1000 students, and this sample size, if you keep on increase 50, then 100, and then 200, 500, your error, this sampling error will be reduced definitely. Whereas non-sampling error example is what? If a survey includes only students in the library, it may miss others who study elsewhere. Like, it is not the case that student studies only in library. Several students studies in their home, in their hostel, in some other places. But your survey includes only the student who studies in the library. Then this bias causes a non-sampling error due to the unrepresentative sample, because you are not having any representative who are studying in hostel, who are studying in home, correct? So these error do not decrease with larger sample size. So if you increase the size larger, like if you take the whole library student, still there will be some that unrepresentative, right? So it will not decrease. So this must be avoided through good sampling practice. So your sampling should be like it should be some way you have to follow so that there should be representative, right? So let me end the class up to now. In the next lecture, we'll discuss about the descriptive statistics, that mean, median, mode, and several other things. I hope you enjoyed the video, right? We'll come up with a new video in the next lecture. So the most of the content are from these books, and few content we have taken from other places. Thank you very much. We'll meet in the next video.